Okay, this is another Euclidean geometry problem, and let's get our heads around what this problem is telling us. Well, we're told that Q bisects YZ, which means it cuts it into two equal halves. That's what the word bisects means. And we're also told that SR is parallel to XZ. Okay, well, we have triangles and we have parallel lines, so I think that this problem probably has to do with the proportion theorem, which states that if a segment is parallel to a side of a triangle, it cuts the other sides proportionally. So without even looking at what this problem is asking for, we can get our heads around this a little bit more. If I consider the triangle QZX, we know for sure that QR is to RZ as QS is to SX. And since we notice from this problem that QR is equal to SX is congruent, those two segments are congruent based on the diagram, I think that we can say that QR is equal to RZ, and that is what they're asking for in the first problem. So because RS is parallel to QZ, we know that the segments of QX and QZ are in proportion. Second one, prove that YS is 3/4 of YP. Well, I think if we consider a different triangle now that contains YP, that might be helpful. Now, going back to what we were given in the original problem, that Q bisects YZ, and we also have learned that QR is equal to RZ, we could label the sides or the segments of QZ as 2x, x, and x, and YP will have to be cut in the same proportion as YZ. So I know that YR is to YZ as YS is to YP. And we know those both will be 3x to 4x or just 3 to 4. So I think now we could say that YS is to YP as 3 is to 4, which means that YS is equal to 3/4 times YP. And the last one, if YS is equal to 12 centimeters, find the length of SP. Well, again, we know that that will be 3/4 of YP. So we could solve that proportion by cross multiplying. 3 times YP is equal to 48. So YP, YP is equal to 16. SP is what they asked for, and SP would be YP minus YS. So SP will be equal to 4.